we can put this all together. I'm waiting for it to be quiet since I'm recording, guys. Okay, so what would be the best method to solve this one? GCF. Let's take out that -2. So when I take out that -2, I'm left with x squared minus, x squared minus 4. Sorry, I should have took out -2x. -2x, x minus 4. All right. I should have factored it over here. -2x, x minus 4. What does this tell me? Technically, I should always be putting a 0 there because I'm finding zeros. It tells us the x-intercepts. So what are my x? This one is obviously x equals 4. What about this one? What do we do with this one? The way I find this one is setting this equal to 0. I can set this equal to 0, and what is x going to equal? 0. Good. I can graph it. I'm going to graph it with yellow. So I've got a 0, and I've got a 4. 1, 2, 3, 4. From that, what else can I get? Good job. And the axis of symmetry gets me on my way to finding what? The vertex. So if my axis of symmetry, what do I have to write in front of it? Can I just write 2? X equals 2. Now how do I find my vertex? Substitute it back in. So let's substitute it back in. I've got -2. 0 equals -2 times 2. Let's use this one. We can use this one here. -2 times 2 squared plus 8 times 2. So 2 squared is 4. 4 times -2 is -8. -8 plus 16 is +8. Right? So my vertex is 2, 8, 2, 8. Does this make sense? Why does it make sense? Because it's pointing down, right? Because it has a negative coefficient in front of x squared. So this is a parabola that it's pointing down. It's got kind of steep slope because of the 2, right? And that's about it. I was going to say something else. Oh, what else did we know about it just by looking at it? Not the axis of symmetry, but the y-intercept is what? That y-intercept is 0. I could have found the roots with a quadratic formula as well, but why would I want to hurt myself like that, right? No need to. So that's putting it all together. You guys know a lot, right? Okay. All right, so I'm trying to complete the square with 3x squared. Doesn't this stand for an x squared right here? And this stands for an x, and this stands for an x. What would complete the square for this one? This is 1x times 1x equals 1 times 1 is 1, right? 1 unit. So this must have been x squared. Actually, it would have been a -1. Why would I say -1? These are negative. So I have right here the abstract here, and we're going to put it in concrete. So we have x squared minus 2x's, right? I split them, and then I completed the square. That would complete the square. Thank you. Positive 1. But it would be x minus 1 squared. Okay. But now I don't have 1x squared. I have how many? I have 3x squared. Same process. Same exact process, only you've got to split them up. Now you've got 3 groups. That's what this says right here. So if I pull a 3 out, I would have an x squared left over. I would no longer be talking about 12 x's. I'd be talking about 3 groups of 4 x's, right? So I would have to complete the square when I find this number right here. So with this one, it's going to be 2 squared. When I find this number, when I add to the other side, I have to remember I'm going to add 3 groups to the other side. Does that make sense? So that's the only difference about today. Jay, I need you to set up, please. Okay, so let's work on this. All right, so what do you think I'm going to do first? I'm going to pull out that 3. So I'm going to pull a 3 out. I'm left with x squared minus 6x. Ooh, before I pull out that 3, for sure I know that this is not going to make a perfect square. Correct? Christian, I don't want you writing right now. I want pencils down. Drop the pencil. Thank you. Okay. I know for sure that this is not going to make a perfect square, right? I need to move it. That's the first thing I'm going to do. So I have 3x squared. You don't want to pull, even though there's a 3 in there, you're going to screw yourself up if you do that. So you just need to move it completely. So I have 3x squared minus 18x equals 3. Is that fair? Now we can work with this. So now I'm going to make my 3 groups. So I've got 3 groups of x squared. Then this is going to be negative 6x, right? And then I'm going to add something to make a perfect square, right? And then I have 3 on this side, plus I'm going to add something, right, to make a perfect square, but I have 3 groups of them. Does that make sense? Because here, when I put a number here, like let's say, what number goes here? 6 divided by 2 is 3, so it's going to be 3 squared, negative 3 squared, or 9, right? But I don't just have 9, I have 3 groups of 9 if I were to redistribute, right? Does that make sense? So I need, when I add, I need to make sure I'm adding 3 groups of 9 as well on this side. And that's the only difference about today from the other one. Hold on 1 second. We're almost there. All right, so now I have 3 x minus 3 squared, right? Everybody's comfortable with that, equals 3 plus 27, so 30. Now what could you do? Divide both sides by 3, and now I'm left with x minus 3 squared equals 10. Take the square root of both sides. And I've got x minus 3 equals plus or minus root 10. Are there any squares in there? Nope. So it's just x equals positive 3 plus or minus. You can't pull out a 2. You can't pull out anything. There's no squares. 2 times 5 is 10. There's no squares in that. Okay, Michelle, first. No. Because we need that. Normally with the GCF you would, but we're completing a square. If you take the x out, we don't have enough squares to make a perfect square trinomial. Because you know you're going to be completing the square. Yes, that's a valid question. See this here? I would never factor out a 3 for this one because I have an equals 3 on the other side. Do you know what I mean? Like when I started here, you would factor out a 3 and then you'd know that you can't complete the square with it. Let me try and think of a different way of putting that. You're right. There's a GCF here. Normally that's the first thing you do. You take a GCF out, okay? When you take the GCF out, you would have, let's rewrite it. I really like this question. Because that's the first thing I've taught you guys to do. You get 3x squared minus 6x minus 1 equals 0. Then you try and factor this. And you would see that you can't factor a 1 is never going to make 6, no matter what. So then you'd have to back up and go, okay, I can't factor it. Okay? So once you tell yourself you can't factor it, you have to go back to this form right here. This is not going to work out. Okay? And even if you were to say to yourself now, I know it's not factorable, so now I'm going to complete the square, you can't complete it's messy to do it in this form. I'd have to do 3 times x squared minus 6x plus something squared, right? But then I still have that negative 1 over here that I know I need to get over onto the other side, which is 3 times negative 1, so it's going to be negative 3 . Yes, you could. Let's see. Let's try it and see what happens. So if I want to divide the 3 by both sides, then I just have x squared minus 6x minus 1 equals 0. Then add the 1 to both sides, and I have x squared minus 6x equals positive 1. Then I have x minus 3 squared, I'm not going to skip steps, sorry, x squared minus 6x plus something squared equals 1 plus something squared. Then I have x, this is negative 3. And I end up with 10. It looks like it worked, right guys? Miss Wiz, why would we not do it like this every time? Can you think of any reason? Then why do we show them such a complicated way? When there's, no. We started with this. I bet you every other teacher does it this way, or does it this way. We've had lots of discussions about it, but why would we? I didn't even think about it. I'm just trying to think if there's a reason why, any time, that you wouldn't just factor it out and get rid of it. Well, no, granted, this is confusing. That's why this is the last lesson of the unit, right? And normally, if you don't want to do something, I need you to stop, please. And normally, if, I like to see both of you after class. Thank you. So, normally, if people are uncomfortable using this, then they would just use quadratic formula, right? This is a long way, or the quadratic formula? Quadratic formula is. I'm just trying to think if there's any reason. Then you would. Thank you. You're right. Thank you. So if there is not a GCF for all 3 of these, then you'd have to do this long way. Thank you. If there's a GCF, you can do it exactly what Aaron suggested we do. And I would have gotten that as soon as I went to this next problem, which would have been this. Nope. That one? Nope, that one still has a GCF. I gave you easy ones. I should have made them more difficult, right? Okay. There's not going to be anything on there that's supposed to trip you up on the quarterfinal. No, but there are thought-provoking questions on the quarterfinal. I wrote it, but it is the department quarterfinal. I wrote it with Miss Wiz last year. We wrote it. Okay, so why don't you guys go ahead and get your steps down in your notebook. I think it would be more valuable to have it written like this because sometimes you'd have to use it like that. So I'm going to give you guys a moment to do that. And I'm going to pause my recording. One. Okay, so let's do one that is a little bit more difficult. Solve by completing the square. Would I complete the square with this one? I could. It wouldn't be as much fun, right? It's actually not that bad. I'm going to do it super quick. So obviously this does not make a perfect square. So I have x squared plus 3x plus something squared equals positive 8 plus something squared. That something squared is 3 cut in half. 3 cut in half squared. 3 cut in half squared. So my perfect square binomial is going to be x plus 3 halves squared. Aaron. X plus 3 halves squared equals, this is going to be 9/4, correct? What can I change this to so it's fourths? 32. 32 divided by 4 is 8, right? So now I have, see what I mean? X plus 3 halves squared equals 32 plus 9 is 41/4, correct? I will. Hold on. I really wouldn't want you to do this for this method. I'm just showing you that you can. So now I have x plus 3 halves equals plus or minus root 41, which there's no squares in there, but the square root of 4 is 2. So what's my axis of symmetry? If you use the quadratic formula, that's exactly what you're going to get. Okay? So what would be the most efficient method? Quadratic formula on this one. You probably make less mistakes, right? When you start manipulating all those fractions, I think you'd have more issues than if you just use the quadratic formula. Aaron? Yes. I have a question on the quarterfinal and the test, and I think the group quiz. What would be the most efficient way and why? And then I have one of them on there that asks to find the axis of symmetry. I have one on there that says something about what would you add to both sides to complete the square. So if it doesn't specifically ask you for a certain method, like talking about a certain method, you can use whatever you like. Make sense? But there are things on there that ask you specific questions about certain methods. Okay. Let's see. So let's change this up. Instead of making it a 7, I'm going to make it a 2. That way it's a little more difficult. Do you guys want to try it on your own? Try it on your own. What's my first step? I would move that 2 and then take out a 7. Okay? Do you guys try it? Okay, so the first thing I was going to do is move that 2. So I have 7x squared minus 14x equals positive 2. Now I'm going to pull a 7 out. So I have 7 groups of completing the square. Minus 2x plus something squared equals 2 plus something squared. But I need 7 groups of that, just like the other side. Negative 2 divided by 2 is just 1, or negative 1 squared. So then this side is going to be 7 groups of x minus 1 being squared equals 1 squared is 1 times 7 is 7 plus 2 is 9. So this is going to come out nice. Not really. Divide both sides by 7 and you get x minus, how many of you got to here? Ask again. Remember I have to add negative 1 squared? That's what I'm adding to both sides, right? But I'm not really just adding one of them, I'm adding 7 of them, because if I were to distribute, I actually have 7 groups. Because it's still talking about 7 groups of them. You got it? Technically, I didn't just add 1 to both sides, because if I were to redistribute it, it would be 7 ones. So I have to make sure I add 7 ones on this side as well. Yes. I can't hear her question. Malik, turn, please. No, we factored out a 7, and so this is our new trinomial right here. Okay. From here, maybe it would help to go back and look at this slide. Christiana, look. See, I wouldn't take half of 12, right? Because when I pull the 3 out, I now have 3 groups, right? So now it's 4. Now I'm talking about each one of them being 4, and half of 4 is 2. Because you're talking about completing the square with 3 groups. Okay, we can talk about it in tutoring. I'm going to show the answer right now. Okay, so now I would divide both sides by 7. And I'd be left with x minus 1 squared equals 9 over 7. Now I'm going to take the square root of both sides. And I would be left with x minus 1 equals plus or minus 3 over root 7. Right? And now I still got to put the 1 on the other side. X equals 1 plus or minus 3 over root 7. How'd you guys do? Okay. What? For math analysis, you would need to do this. Because in math analysis, they don't like you to have square roots in the denominator, so it would be 3 square root 7 over 7. X equals 1 plus or minus 3 root 7 over 7. No. Take the, yeah, I have 7 groups equals 9, so I have to divide both sides by 7, yeah. Okay. No. You would have gotten this. Wait a second. No, you would get this if you use the quadratic formula. Yes, you would. Not always. It's not always. And this one, yes, but sometimes it's just faster to use completing the square. But I'm not telling you you have to when you have a coefficient bigger than 1. Not at all. If you would rather use, I would totally agree with you. If you were to say I'd rather use the quadratic formula for this one because I feel like it's more efficient, I think you would be correct. Okay? Yes. Yes. Square root of 9 is 3. The whole purpose of this is not for you to do it every day. The whole purpose is for you to get exposure to it. Okay? Make sense? Okay. The only thing I want to show you is choose your method and match the graph. What method would you use for this one? Taking the square root of both sides, but which graph would match? This is a quadratic shifted what? To the right 3, right? So which one of these is shifted, is the parabola shifted to the right 3? The first one. And then equals 25 would be a constant line at 25. You see how that's, you can't really tell, but that really is 20, that's 30. It's a constant line at 25. So the solution would be this graph here for this one. And then let's see if it matches. If I take the square root of both sides, I get x minus 3 equals plus or minus 5. X equals positive 3 plus or minus 5. And then this one looks like it's at 8 and negative 2, right? The solution, which is exactly what you would get. 3 with adding 5 to both sides. Okay, homework time.